All right, we're going to take a quick look at some examples of using our molarity equation, which is molarity equals moles over liters. So moles of our solute over liters of solution. So we're going to take a look at 3 examples. We're going to take a look at an example to solve for each of the variables so we can understand all 3 methods, or all 3 things we can solve for. So our first one is looking for molarity. What is the molarity of solution containing 0.382 moles of sodium chloride in 1.75 liters of solution? So this one's looking for molarity, so we don't have to rearrange our equation. We're going to simply plug in our numbers. 0.382 moles divided by 1.75 liters. It is important that you write your units, so please make sure you're getting a good habit of that. So we're going to divide those two, 1.75. Now when it gives you a whole bunch, these both have 3 digits. It's easy. We can just round to 3 digits besides our 0, so 0.218 is just fine. Now our units, you could put moles divided by liters, or you can just put molarity, that capital M, which is what I typically do, all right? And then it is appropriate to go ahead and write your chemical for our solution. So if we take this many moles of sodium chloride to put it into 1.75 liters of solution, then this is our concentration. So molarity is concentration, all right? Concentration, okay? Our second question says how many moles of copper chloride are in 0.25, this is supposed to be liters, of 1.25 molar solution. So I'm going to start with my original equation, but we're trying to find moles. So I want to get moles by itself first. So to do that, we're dividing by liters, so I'm going to do the opposite for my liters, multiply by them, and now moles are by themselves. So my equation, my moles, is equal to liters times molarity, or molarity times liters, same thing. And then we can plug in from there. 0.25 liters times 1.25 molar, and let's see what we get. 0.25 times 1.25 gives me 3.12, or 0.3125. Again, we can round it, so 0.313 is just fine. And we were solving for moles, so I'm going to put moles, and my chemical is copper chloride. All right, and then our last one, we are looking for volume. We have a 0.175 molar solution, and we want 4.5 moles in it. So we want to basically measure out how many liters do we need to measure of this concentration solution in order for it to contain 4.5 moles of solute. Okay, so again, if we start with our original equation, I'm going to still do that same thing first. Multiply by my liters and get rid of that fraction. Okay, so then my equation is liters times molarity equals moles. But I'm trying to get volume, liters, by itself. So now I'm going to divide by molarity and allow those to cancel. So our liters are equal to our moles divided by our molarity. Okay, so our moles is 4.5. Our molarity is 0.175. So we're going to divide those. And we get 25.7. The units are liters because that's what we're looking for. And our chemical is calcium carbonate. So these are our 3 ways we can solve this problem. I'm going to box these equations. So we've got liters is moles over molarity. Moles is liters times molarity. And then original equation, molarity is moles over liters. So that's just rearranging the equation. You don't have to memorize these, but we should know how to rearrange it. This is just doing algebra, multiplying and dividing with that. So that's how we approach these problems. Let me know if you have questions or need some more help. You should have 10 practice questions to work on. The only thing I will point out is all of these have moles involved in them in some way. If you are given grams, we can change those to moles before we plug into our equation. Or if we're given moles, we can change them into grams at the end, right? So say we solve for moles like this one does, we could then change them to grams if we were asked to. Okay, so this is just another tool in our toolkit that we've learned before. All right, thanks guys.